Let's say that you have an adorable 10.9 kilogram corgi sitting on the ground at rest. What is the magnitude of the force that the earth exerts on the corgi? Or in other words, what is the corgi's weight or weight force? And then solve for the magnitude of the force that the ground exerts on the corgi. I'll begin by drawing an interaction diagram and then a force diagram. I've listed all of the objects in my system, and I've gone ahead and drawn in my interactions. Now I'll take this and translate this to a force diagram for the corgi specifically. I'll draw my system boundary, and when I do, I see I have two forces, the normal force and the gravitational force. I've gone ahead and drawn my force diagram like so, and because I know that the corgi is not accelerating in the vertical direction, these two forces must be balanced, and I'll indicate that with an equality sign, right? If they were not balanced, the corgi would be accelerating in the direction of the net or unbalanced force. And since I'm solving for the magnitude of the force that the earth exerts on the corgi, I'll also write in here that this is equal to the mass of the corgi times little g. That's the expression we derived in the previous slide. Now, I know the mass of the corgi, and I know that g is 9.8, so I can solve right away. I know that this will be equal to 9.8 meters per second squared multiplied by the mass, which is 10.9 kilograms. And in this case, my units will end up giving me newtons, and my answer will be 107 newtons, rounding to the nearest newton. Now, because I know that the force that the earth exerts on the corgi and the force that the ground exerts on the corgi are equal, then I know that my normal force in this case will also be 107 newtons, right? And that's because the corgi is not accelerating vertically, and I only have one force pointing up and one force pointing down. So if I were to also write out the sum of the forces in the y direction, this is a good habit to get into, it would look like this. F ground on corgi, I'm going to start abbreviating it with the first letter being the agent and the second letter being the object. So FGC would be F force ground on corgi minus force earth on corgi, right? And I know that that would be equal to the mass of the corgi times the acceleration of the corgi. But in this case, the corgi is not accelerating, so that would be 0. And therefore, the force of the ground on the corgi is equal to, if I move this to the other side, right, would be equal to the force of the earth on the corgi. So that is also how we can show that algebraically using Newton's second law in the vertical direction, right? This is my sum of forces, so this is my delta or sigma Fy, and then this is that Ma, Newton's second law. And I know that the sum of the forces or the net force is equal to Ma. So you'll see here two ways to go about solving this problem, but that's how we quantify the gravitational force. All right, please watch the next video for a more in-depth look at the normal force and how specifically the normal force changes and is not always equal to the force of gravity on the object.